Welcome everyone to another of our lake stewardship workshops as we continue our series on lake protection success stories. I'm Jim Irwin, Chair of the Riding Mountain Biosphere Reserve, and I'll be hosting tonight's workshop. And Dennis Hodgson will be assisting with the Q&A. To begin, I would like to acknowledge that the Riding Mountain Biosphere Reserve is in Treaty 2 and 4 territories of the Anishinaabe people, and say that we respect and share their all important teachings that water is a sacred gift essential for all life. Since 1986, Riding Mountain Biosphere Reserve, has been bringing people together to share their knowledge for the well-being of our communities. In this respect, we are pleased to have Daryl Kines and Toews with us today to continue the discussion on the nutrient loading problems of our prairie lakes. Today, Daryl Kines, who has a deep concern about the health of Sandy Lake, will give a presentation entitled, "How Do We Reduce Algae Blooms?" And Toews, a professional aquatic biologist, has generously volunteered to help answer our questions in the Q&A. Daryl lives on the shore of Sandy Lake and heads up Sandy Lake Water Protection Working Group, Inc., which is focused on both nutrient loading problems and AIS threats. Daryl has been an intrepid force in working to protect Sandy Lake's water and has been frontline and center in the Biosphere Reserve's efforts to help protect our many prairie lakes. Jay is a biologist and has a consulting company called Toews Environmental Consulting and Aquatic Sciences. Jay has performed studies on a number of our lakes in southwestern Manitoba, with notably recent studies on Lake of the Prairies, Shoal Lake, and Kerr Lake. And many will know Jay has also done a presentation for us on his Kerr Lake study in our Lake Workshop number 6. I would now like to invite Daryl to start his presentation. Daryl?
Thank you, Jim. Okay, the presentation, as Jim mentioned, is on how do we reduce algae blooms. We're going to talk about the problems algae blooms present to us and what the basis of the problem is, and then we're going to try and, well, we'll go into what can we do about that. I guess the first thing to state is that not all algae is bad. The green algae is actually good. It is the basis for the natural food web for fish, and too much of it can cause water oxygen depletion when it dies, goes to the bottom, and starts decomposing. The blue-green algae blooms are a problem. First of all, our lakes, if you have a beach, they're typically monitored by the province, and they'll post public warning signs if there's a human health risk. The algae can be toxic to humans and pets, so you shouldn't be letting your dog drink the water when these signs are posted. Other problems are they're gross, they stink, they're slimy, and as we said before, you can get oxygen depletion when the algae decomposes. As you can see, it's not healthy for fish. So why do our lakes get algae blooms? Well, algae growth is proportional to water nutrient levels that are in our lakes. And when the levels are high, we'll get an excessive algae bloom. You can see the two pictures. The one is taken from a drone shot, the one on the right, and you can see the algae are blooming pretty good. On the left, that picture is of Golf Course Road, and at the end of Golf Course Road, there's quite a number of cattails, so there is some good stuff at the end of the road, but the rest of the area is, well, it's in full bloom. Lakes in southwestern Manitoba exist in nutrient-rich soils. Nutrient loading from stream inflows are continuous, and they come from both natural and human sources. When the nutrient inflow exceeds the nutrient outflow, we've got an increase in nutrient levels in the lake. When we get summer temperatures, this also allows algae to grow a little faster. The sun is necessary for algae to grow as well. So, and then high nutrient levels combined with the warmer waters and the sunshine create conditions for blooms. That brings us to what can we do? Well, we can't control the weather, but we can prevent nutrients from entering the lake, and we can remove nutrients from the lake waters. Those are the two things that we have some control over. The first one is less costly than the second one. We can build public awareness of nutrient pollution activities. For example, if you have a gray water pit, that's something that you should change, because that definitely is a problem for the lake. If you're fertilizing your lawn and you cut your grass right to the edge of the water, that's another one. There are quite a few things that we can do. Well, one of the things that is a good thing to do is to initiate a project to help reduce the nutrient load. So we're going to use Sandy Lake as an example, and basically the reason that I got involved in water quality, well, I live at the lakeshore, and algae blooms are a problem every year. Everyone complains about them and wants to do something about them, but, well, water samples are taken, results are published, studies are done and they're published, and all of these things gather dust. I thought it was time to actually do something, and that's where we are right now. We're trying to do something. Well, what are we doing? Well, first of all, our most pressing problem was the threat of an aquatic invasive species coming to our lake. There's not much point in having no algae blooms and having a lake that you can't use. So that was sort of our first priority, and we think we've got that, well, as best we can. We hire summer help, and we inspect watercraft, and we have a place to send them for decontamination. And that's working, I think, fairly well. So far, we've avoided a zebra mussel invasion, and we can now start thinking about doing other things as well. So one of the things we did was we learned about algae blooms from the studies that were done, and talking to people who know a lot more about it than we do. We've talked to quite a few different individuals that are professionals in this area. And then we selected a project and developed a plan to implement it. So the project that we have selected is on the golf course. We have a stream running through the golf course, and there is an existing wetland. It's kind of small. And what we're going to try and do is to reduce the nutrients that are coming in from outside the golf course. And also, we're going to use lake water to make sure that our wetlands remain wet. The plants could die in a drought situation, or certainly they wouldn't be removing any nutrients during that period. So we're going to use the water from the lake, which is high in nutrient content, and we're going to keep the wetlands wet, and we're going to use that water to keep the stream running so we don't have stagnant water there. And at the end of the run, we're going to have another wetland that we construct, and it hopefully will remove nutrients as well. Nutrients come in from the golf course as well as from south of the golf course, and And so we're trying to treat all of the water that is coming through in one or both of these wetlands. Picture on the left shows the project. Basically, the purple area that is at the bottom of the screen is going to be the expanded wetland, and the two yellow bars that are at near the Trans-Canada Trail, they are going to be the overflow for the wetland, and the white bar is a control structure that will allow us to let water out of the wetland. The water will come in from the golf course's irrigation system, and it'll be kept to about 1.5 feet depth, and we'll allow a trickle of that water to run down the stream, which is in yellow, that yellow line. And then there's another wetland that is the blue area, and we'll have a control structure, looks like a dot at the end of the blue line. That control structure will allow us to keep water in that wetland, and essentially we'll be planting cattails and other natural grasses that grow in this area, and those will take some of the nutrients out. The picture on the right shows that stream. You can see it at the bottom, and it actually flows between two cottages, and you can see the algae blooms. They're not very nice. The experts tell us we need to do a study on our lake to figure out where the nutrients are coming from, how much each of these locations are contributing, and also how much is already in the lake. And hopefully we'll be able to use a study as a guide to determine what to do next. It's pretty easy to understand the project we've chosen. We've chosen it because it's easy to understand, and it's actually a physical thing that we can get funded for. And so we've applied to the Conservation Trust. The project is $75,000, and they will pay up to 1/3 of that, and we have to find contributions in kind or cash donations, and we're confident we can do that. We've also applied to the Lake Winnipeg Basin program, and they will fund up to 1/3 as well. So if we get both of those funders helping us out, we'll be in really good condition. If we don't, we'll probably still do something regardless. Okay, this is a picture of, it's an old picture, and you can see that the main street sort of wise off, and it continues down the right-hand side and goes right down to the dock. We've got a lot of water that goes down that little runway, and there's quite a few other places that are similar where we have culverts that divert water into the lake directly. So those are all part of the problem that we think we might be able to figure out how to solve. But there's quite a bit of science involved in this, trying to understand how the lake works. Jay is the expert. We certainly don't know enough about how to do a proper job of improving the lake so we have fewer algae blooms.
Thanks. Good job, Daryl. The first question we've got is, how can a study help us improve our lake? What really is the science of our lake, and what should we know about our lake?
Probably one for Jay.
Yeah, okay. I think what I hear in the question is in reference to studies that have already been done and this sort of thing, and how will spending that money help our lake? Well, first of all, on the first point, I should point out that not all studies are the same. They come from very different approaches and tell you very different things. And in my experience, the studies that have been done in Manitoba so far with our local science groups and scientists, they tend to be pretty general. They tell you about concentrations of nutrients that are in the lake, how those concentrations have changed over time and the trends that have occurred. They compare them to guidelines, and then they may give some very general recommendations, which may be copied out of other very general documents. So it's important information, and it helps us to understand the lake a little bit. But the kind of studies that I think are being asked about and what we're driving at are those that support decisions that cost a lot of money. Things like, should we install an aeration system? What sort of aeration system? Should we try this treatment or that treatment? And that is science that really hasn't arrived in Manitoba yet. It's definitely in other places. It's science led out of Australia and Europe. And it's really been built into an industry in the United States where they have lake managers and watershed managers that are responsible for all of those lakes. And they've got lake manager certification programs. And this is all stuff that we haven't seen yet here in Manitoba. And what some of this drives towards, in terms of the second part of that question, the science, is how the lake is functioning. So sure, the nutrient levels may be this high and the algae may be this high, but it's not that simple. And Daryl, you're right in that you're correct in saying that there's proportion there and that higher nutrients lead to higher algae blooms, but it's not really a linear proportion. There tend to be thresholds that occur, and it's much more complex than that. I'll throw an example at you. Have you ever thought about the fact that sewage lagoons do not have blue-green algae blooms? How does that work? So with that in mind, if anybody caught my previous presentation on Kerr Lake, you have to really focus on different depth relationships with mixing and sunlight penetration. You need to look at the relations between chemistry, nutrient, algae relationships, and that sort of thing. And you're focusing on the functioning of the lake. So I'll give a couple of examples of studies that I'm working on right now, and it will show you the difference. These are all prairie lakes within, I don't know, a couple hundred or a few hundred kilometers of each other, all the same latitude and similar situations. On one of them, I'm working with the team. We've recommended aeration, and I'm working on a team to actually calculate out the dose of oxygen that is needed to overcome the oxygen deficit in that lake. Another lake is kind of like, it functions as the other lakes do, with 1,000 or more aeration systems already installed. On the surface, the lakes look very similar, but they function so differently because of different factors like wind exposure and this sort of thing. So they're on the one we're doing the calculations to get the right aeration system in. On the other one that's acting as if it already has 1,000 aeration systems, are we going to recommend an aeration system? Likely not. What good will it do? And on the third lake, it's somewhere in between. The turnover is a little bit sporadic in the lake. And might we recommend an aeration system? Possibly. We'll look at it a little more closely to see what kind of bang we can get for the buck. So what I'm talking about, actually I should make a little point. On the one that we're recommending, it's not an aeration system. It's a bit of a different technology that does the same job without destabilizing the ice. So it's still safe for skidooers and that sort of thing. So those technologies exist out there, by the way, that might be of interest to people. And then you don't have the liability issues that are there in the Canadian Criminal Code that are associated with aeration systems. But so the right study can give you good recommendations on and specific answers around things like, should we install an aeration system? What type should we install? What other things should we consider? So not all studies are the same. And the trick is to get the right one done by the right person.
That kind of leads us probably to the next question here. Jay, who can help us decide what we need to do next?
I really encourage community involvement and community-based monitoring, that sort of thing. That said, these questions that come to me sometimes, they make me feel like giving a response like, well, if you come and tell me that you're peeing blood, I'll say, go see a doctor, and if it comes to that extent, you should probably see not just any doctor, but a specialist, right? And so I'll try to give a little bit of a different illustration that might help you see where I'm coming from this. If you walk up to a mechanic and say, hey, my truck isn't running really well, what do I need to do to fix it? And the mechanic will say, well, what exactly is it doing? Oh, it's just not running really well. Okay, let's start from the basics. Is it a diesel or a gas motor? Well, I don't know. My partner always fills it up at the gas station. Where do we go from here? Well, somebody with some experience or just any familiarity that we have with trucks, well, you know whether it's a diesel or a gas just by hearing it run, right? Smelling the exhaust from a distance. A mechanic with a little bit of experience might hear the motor running and realize that something isn't right. A really experienced mechanic might, just from hearing the motor run, know exactly what the problem is. But I'll bet you that even that really experienced mechanic is going to want to open the hood, get in there with his tools, or these days a computer, and check a few things out before telling you what parts are needed, right? And that's a little bit like hiring the right limnologist or the right aquatic scientist. And as I said, it's a science that hasn't really arrived in Manitoba yet. So I'll give you a lake example along the same lines. I'm not sure if the same person is here. I think it may have been Randy Abbott, but it was somebody from Otter Lake that asked a question that I thought was really interesting last week. It was a very good question. When Brian Martineau was presenting on Minnedosa Lake and talking about the weed problems they have there. And the fellow from Otter Lake was saying, well, we have a shallow lake and we don't have those weed problems. Why not? And he mentioned that they have a lot of turbidity in Otter Lake. Now, I haven't been on Otter Lake since I was a little child ice fishing, and I don't think I've been closer to the lake since then, closer than driving by on the Mountain Road Highway. But just hearing that, this is sort of hearing the truck at the distance, it tells me if he's talking turbidity, he probably means diatoms, a heavy diatom growth in Otter Lake. And that is driven by wind exposure in the lake. And turbidity in Otter Lake means something very different than turbidity in Minnedosa Lake. But it's those diatom algae, and they make the water look brown. So you're probably thinking it's turbidity, but that's the dominant factor in the lake. If that's the case, the people at Otter Lake had better be thankful that the lake isn't much deeper, because that would probably cause it to trip over into the blue-green algae growth. So those are the sorts of things I recognize from a distance. And I'd be very happy. I love the parkland and I love the lakes. I love the flipper lakes and all the good things that have been done up there. So I'd be very happy to be part of that. The other thing I'll add is I was introduced as a biologist. I'm actually more of a chemist by training, and I use both of my chemistry and my biology degrees to their fullest. And I've spent 25 years on the water studying these things, and I spend many, many hours every year keeping up on the science that's happening in other places. So that's the kind of thing we need more of in Manitoba, and I'll make that a pitch for the science more for me, but it hasn't really shown up here yet.
So can we do some of the work to help reduce the cost of a study, Jay, and what portion of that study could we do if we could do some ourselves?
A lot of it. That's a great approach. And it's the reality that we're in with the budgets available on these lakes and that sort of thing. And that's where I'd like to bring in community-based monitoring. And on the projects I've done, it's always a combination of training local people or training water district staff, as I pointed out on Kerr Lake last year. So a lot of the field measurements and that sort of thing can be done well, but I'm going to put a context around that. When you take a dissolved oxygen meter and a pH meter and drop them in the water, what questions are on your mind? Most likely it's what's dissolved oxygen and What's the pH, right? In addition to dissolved oxygen and the pH that we're reading, these are the questions on my mind, or just a few of the questions. And I'm looking around looking for the clues. Is there an oxygen deficit in the lake or in the water that I'm in? What's causing it? Is it breakdown of organic matter, or is it the active respiration of algae or plants? Are there nitrate effects? Is there internal phosphorus loading? If there is phosphorus loading, is it due to the breakdown of ferric compounds, which is controlled by dissolved oxygen, or the breakdown of minerals like apatite, which is controlled by pH? What's driving that? Is it something aqueous, or are there things like Lyngbia or cyanobacteria mats on the bottom of the lake? Is there sulfur inhibition of phosphorus iron binding? What killed the fish? Was it simply low dissolved oxygen, or were there chemical toxicity effects in the water that combine with low oxygen and that sort of thing? I could go on all day with questions like this, but these are the questions that are on my mind when I'm taking a dissolved oxygen reading. So with that in mind, yes, local people, I mean, for you guys to be able to train people to take the readings, that's the way we make things work. But we have to recognize too that, well, let's go back to the example of, I'm peeing blood. What should I do? Whom should I see? If you have to go in for surgery about that, are you comfortable with the surgeon's assistant doing the surgery? If you're on the operating table, are you comfortable with the surgeon standing beside someone else in the room, telling that person how to do the surgery? And are you comfortable with the surgeon being somewhere else, telling that person how to do the surgery over the phone? So all that said, the reason I bring that up, I've done many studies like this, training other people, and I've had good results and bad. Kerr Lake, kudos to their technician. She was she grew up on a cattle ranch at Gilbert Plains. She did a fantastic job of getting the data. I've hired local fisheries biology firm, good firm. I came out of that without any pH data and conductivity data for a whole season of data gathering because they didn't recognize problems with their equipment. Big engineering firm, a full field study of dissolved oxygen, and we had no dissolved oxygen data. So we need to talk together in each case and see where our comfort level lies, I think. And sometimes you can go out and do the study again, especially if it didn't cost you too much. Sometimes you lost your chance. So I really like that approach of working with local people and training. And honestly, I've had better luck than hiring sub-consultants. So, but it really has to be worked out on an individual basis.
What would you say are the most significant indicators within the science of all of this, which might be signals of our next step in lake remediation?
Whatever the science tells you. And what I mean by that is you start off with enough field experience and enough experience with the lakes to know what to look for. And then you're doing the study to find those answers. Like I said, I've got 3 on the go right now. For one of them, we're recommending aeration and carefully doing the calculations to know what sort of system and how big the system to put in. On the other one, we'll say, no, aeration is a waste of money, right? So that's it's everything combined, and all of these lakes really are different. They look very similar, but they act very differently, these prairie lakes.
Daryl, I'm going to put you to work there now. Does the golf course, Sandy Lake Golf Course, or the cottagers use fertilizer?
Okay, I've talked to Wayne, who is one of the owners, and he uses a firm that's out of Rivers. A fellow there, his name is Kyle. He says that they put hardly any fertilizer on the fairways. They water with with lake water, and it has a lot of nutrients in it, so they really don't have to put very much. On the greens, they do use fertilizer. I'm not sure how much, but Kyle is certified to put fertilizers on golf courses. I guess there's a program in place for golf courses. They apparently don't put very much on the land. I guess another part of it is, do they spray anything on the land, for weed control? I think they do. I'm not sure exactly what they use. I think not last year, but the year before, I think Wayne sprayed for dandelions. I'm not sure exactly what he used. Will what we're doing reduce the effects of those? I'm hoping so. The wetland that we're constructing or plan to construct should take out a lot of those things as well as nutrients.
That leads into the next question. Probably, Jay, you want to tackle this one. And it's a comment that many of our prairie lakes are surrounded by farmland and lots of aerial spraying in some cases, as well as ground spraying of pesticides occurring. Does that not affect our lakes' water quality?
Yes, it does. Yeah. The chemicals they're spraying affects water quality. It comes down to the individual lake and the individual application, I think, to know how much it's affecting. You hear anecdotal reports of spraying on a windy day and it killed their slough, that sort of thing. It's all part of land management in the region, and we can draw regulations and different things, but I've heard it said that you cannot regulate common sense. So I think that's community stewardship in terms of each of our own lands, that we do the best we can, right?
This starts off with it's more of a comment, I guess. I question the need for a study. We need to reduce phosphorus inputs into, for example, Sandy Lake, period. Plus, since there are no fish winter kills in Sandy Lake, with the exception of projects such as the wetland project described by Daryl.
Do you want to take that one, Daryl, or I can offer my insight? Maybe I'll offer general insight. I agree. If anybody caught my previous slide, the theme that I followed is there are 3 steps to success. One is learn what the problem is. Second is learn how to fix the problem. And 3 is make sure you get the job done and fix it. You can jump to step 3. Certainly phosphorus loading, we know that is a problem. And so any project that can reduce phosphorus loading, go do it. The golf course project, great. I don't think you have a sense yet the relative proportion that's coming off of that the golf course drainage compared to the rest of the drainages around the lake. So it might be nice to know. As I pointed out, the Kerr Lake example, the reason I used that example and like it so much is there were 6 streams into the lake that all should have been the same. And yet one of them contributed 82% of the loading to the lake. So you wouldn't want to miss that one. Great to put in a project on all 6 streams on the lake and everybody do the best they can, but one of those streams needed some extra attention. And you've probably hit on one of them with the golf course, but you have to wonder what the rest of the lake is doing, or what the rest of the watershed is doing, right?
Yeah, I agree. Why would we want to do a study? Well, I think that we really don't know where the high level of nutrients are coming from, or if there is one that's higher than all the others, which, we could maybe act on that one first. We have had studies done in the past. There was the Algae studies, and basically after that one, there were a few others, but the one in 2005 that I came across it was just lucky. The person at the Little Saskatchewan Conservation District had been involved in that study and had a copy of it, and they supervised the study. but it was really never published, and Colleen gave me a copy of it, and so I read it. It's actually written in fairly plain language. There are some things in it that are harder for me to understand, but I can go on the internet and look some of it up. And I can ask other people about it, but there are some things that are, not, there are a lot of there's a lot of low-hanging fruit in that study. And then Cassie McLean did a study as well, and she got permission for me to post that as well. But quite frankly, most people haven't read that study. And many of them, the majority of people, don't even know that it's posted online at the Friends of Sandy Lake website. They're all of the studies that I could find, I put up there, and I've read most of them. We can learn a lot from these studies, but those studies, I think Cassie's was done in 2014, and we probably have a little bit different situation, although maybe not that much since those studies were done. But for example, having someone interpret those studies and point out the things that we know based on the studies, and maybe verifying a few things, and then telling us things that we ought to know but we don't know yet, so directing us to learn a little bit more about things. That's one of the reasons to do a little bit more work on this before we start spending money, serious money. The golf course project is actually a fairly inexpensive project. A lot of it is going to be volunteer work. So things like talking about it with people who are experts, those all count towards the in-kind contribution. So we're probably up around $10,000 or $15,000 already on that stuff out of the 50 that we would be responsible for. Now, I don't think we should go ahead, and this is just my opinion, with putting an aeration system in if we don't have the evidence, the scientific evidence that it'll help. So for example, if we're going to put an aeration system in to prevent fish kills in the winter, we know exactly what we should do. That is certainly, the science is behind that one, and we probably could get some funding to go ahead with a project like that. But we would have to prove, I think, that we have low oxygen levels in the lake in February, March, and April. So we're going to do the studies on that just to see where we are. But we don't know very much about what's already in the lake and how much that contributes, because it cycles itself, as I understand. So that's an area we aren't really sure of. Now, when I've talked to people in the know about the kind of study we ought to be asking for, one of the terms that comes up is the nutrient load. Another one is a phosphorus budget. One of the things we do know, based on the other studies that were done on our lake, is that phosphorus is the limiting factor to an algae bloom in our lake. It's sort of, the studies also tell us a little bit about the kind of algae we have growing in our lake. And I don't know enough about what to look for and how they behave. Like, there's different algae as I understand it. So I think we need to know more about that. And we need someone to help us interpret what that means. So that's sort of why I think we need to do something. Now, whether that's a full-blown study where we don't do anything and we pay for everything, that's really out of our budget. We can't afford that. So we have to figure out ways to get the information we need. And I suppose if I had enough time left, I could probably get a PhD in something, and I might know enough, but by then maybe the lake won't survive. So I mean, I can't do it myself, and there are people that are around that know a lot more about this and are capable. And that's why I think we need the information on how to proceed in a more scientific manner rather than just guessing. Because I mean, we can guess about lots of things. You know, are people putting fertilizer on their lawn? What could we do about that? Do people have holding tanks that are not performing properly? Are people, you know, putting gray water on the ground? Do they have outhouses that are still functional? Are they just a pit? Maybe we should help them take them out. You know, all of those things are possible. The town, for example, has culverts that direct water right into the lake. I mean, that's what you want to do, right? You want to get rid of the water. The water needs, you know, maybe this is good water. I don't know, but maybe it's not. So you know, we know a lot, and we could tackle quite a few things, and maybe we would get the algae blooms to reduce, but maybe we wouldn't.
What would be the makeup of a community lake study, and like what is sampled and what's measured?
Well, let me start that. I have learned that we ought to look at all of the incoming streams to our lake, and we need to determine how much water is coming in and how nutrient loaded it is. So we take samples of each of these streams, and we would measure the speed of the water that's coming into the lake, and you can get a device to do that that's portable. And you would also need to figure out the cross section of the area that you're measuring the volume. You need to get the volume of the water so you can figure out how much nutrients or how much nutrient value is coming in on that particular stream, and then you can compare the streams. That's pretty straightforward. But there's a whole lot of other things that we don't know how to do. Maybe you could help us with understanding some of those things, Jay.
Yeah, I think you answered it right there. The external loading piece, meaning measuring the phosphorus coming into the lake, that's just a great example of something that the community can do. And there too, remember that it's not just the concentrations of phosphorus coming in. That's a piece of the equation. The other piece is the amount of flow coming in. And so if you could gain some training on taking flow measurements so you can quantify what's coming in the lake, that helps a lot. But those are the things that lend themselves really well to ongoing monitoring by the community, probably with your own equipment. It would save money over the long term. And then it's the lake studies that are focused on the function of the lake and you know, answering those bigger questions about what would help. Now that we have a problem in the lake, how do we deal with it? That takes more training and more experience and that sort of thing. And that's where the community can help out with boats and extra labor and that sort of thing. But certainly the loading, getting a feel for what's coming off the landscape into the lake is a great place to start.
What else should we be looking at? Like there's all this stuff that comes into the lake, and then there's stuff that's already in the lake. That would be another piece, trying to figure out how much nutrients we have in the lake and how those nutrients are coming out of the suspension and cycling back to give us more algae blooms. How do we measure that sort of thing?
Right, that's the sort of thing that that I do, and there are many intricate ways of measuring that, as well as some simple data methods. The simple data methods you luck into and you hope for. Sometimes there are too many confounding variables in your. What I mean by simple data is measuring phosphorus in the lake through the year. And it really depends on whether you're talking about a dimictic lake, which only turns over a couple times a year, or these more frequently mixing prairie lakes. You can work with those basic data right down to the most intricate methods of having sensors plugged into the lake bottom, measuring it directly in the sediments. And typically what you want to do is have at least a couple of lines of evidence going, because all of them will be estimates. They're measurements, but they're estimates. And so you want to have a bit of corroborative evidence before before the jury is out, right? Or before the jury comes back in.
So are we talking about samples that we take on the bottom of the lake and then analyze?
Yeah, there are many methods. That's one way of doing it, is taking chemistry samples and measurements of pH, dissolved oxygen, conductivity, these things, doing them top and bottom or through profiles of the lake. Those are commonly gathered data, and that provides one means of doing it. And it may or may not work depending on how your lake acts that year or in general. But that's one way of doing it.
This is a comment to the question about golf courses and the regulations under which golf courses operate. Golf courses in Manitoba are required under the Nutrient Management Regulation under the Water Protection Act, or of the Water Protection Act, to submit a nutrient management plan for their nutrient applications during the season. Then another question here about buffer zones, riparian areas, I guess, so to speak. Should a buffer zone be put in place all around these lakes, planting something like alfalfa?
Jay, I guess that one's for you.
Absolutely, not necessarily alfalfa, but some kind of permanent vegetation for all kinds of reasons. Lakeshore Reserve is an important issue. The way we've settled these lands with the homesteaders originally kind of handcuffs the municipalities a lot of the time in terms of being what they're able to do with the lake legally, and also just in terms of good management of the lake. So it comes down to everyone doing their best. I'll point out though that I mean, we can all see the value of a buffer zone when you're, for me, I'm paddling around on one of the flipper lakes trying to catch a trout, and I'm eating the dust and chaff coming out of the back of the combine that drives by, right? That's obviously a source of loading to the lake and a problem that would be nice to address. But then buffer zones shouldn't be as linear as, or any more linear than the landscape is. And what I mean by that is a prescribed 30-meter or 50-meter buffer zone all around the edge of the water body isn't necessarily the best tactic when there's all kinds of depressions that surround the lake. And you want to focus on those low areas that capture water and that capture all the runoff. And this is not what any cropping farmer wants to hear, but you have funny little uneven edges around your field when you do this. But these are the sorts of things, if we could come up with means of solutions that work best for everybody, to have buffers that make sense with the landscape, and that would definitely be helpful. And the other thing is identifying hotspots on the landscape. I mean, we've been at this for, well, in your area, 140 years or so now, and there are legacy issues that are hotspots in some areas, and finding those on the landscape is probably not a bad thing to do.
We'll talk about a study, and I'm sure in many cases the study has been completed, but does that stop then the need for that kind of work at that point, Jay?
A lot of the things about the kind of studies that I'm talking about, these in-depth studies of the lake, they really tell you how that lake functions. And it will change somewhat when you start changing variables in the lake, but it becomes predictable at that point because you know how the lake is functioning. And particularly with these depth relationships, I mean, if sunlight penetrates a little bit more into the area that's mixed by the wind, well, then you understand what's happening there. So it's not you don't have to recreate the wheel to figure out the lake. So that kind of study is sort of a one-time thing. And that's when your community monitoring kicks in to see how things are changing. So if, let's take the study where we learn how a lake is functioning, we learn where the phosphorus is coming from, you start doing some things to try to intercept that phosphorus with buffer zones or the wetland project or whatever it may be. And then you do your monitoring to see how your improvement is going. Yeah, like I said, that's when the community takes over, and you don't have to keep doing this year over year or anything like that. It's an investment to take you forward through the next decade or so, at least, the next 20 years.
Is copper sulfate still used to kill algae in lakes? It used to be. It was said long ago that Lake Mendota in Wisconsin had received so much copper sulfate that you could almost mine the copper thereafter.
Yeah, and there were those concerns at Killarney and other places as well. It's not accepted in lakes that are used for any kind of water source or for ecological reasons, and it's a sort of thing where it buys you a little bit of time, but then by not dealing with the real problem, you have a bigger problem in the end. I mean, that's a lot of these strategies trying to abate algae problems without getting down to the root source of it. You buy yourself a bit of time and then have a bigger problem than you started with.
Can you speak to the impact of the number of boats on a lake like Sandy Lake?
I can speak to the fact that people are studying that now and trying to find good methods to study it, or to quantify it. So yes, it can have an impact. I mean, I've been tossed about by wake boats and more on the Canadian Shield, so it wasn't so much of an issue, but I can see where it would really tear up these shorelines, especially the shorelines that don't have bulrushes to protect them, that sort of thing. And yeah, there are groups of people trying to learn, trying to find good ways and inexpensive ways of bringing that into your phosphorus budget. I mean, adding that to your lake study. Right now, I can't say much more than if you see a boat go by and a big plume of sediment that it stirred up, well, that's contributing to your internal loading, right? But possibly, because that phosphorus may have come up chemically anyway. So that's why I say people are working on it. Stay tuned. I'll let you know as soon as there looks like there's anything promising.
This is somewhat related, I think, to a previous question and previous answer in a way, I suppose, that there are many communities around the world who are dealing with excess nutrient loading into their lakes. The first and least expensive step would be to do a literature review to determine best practices to remove some of those nutrients. And so the question is then, would you really need to reinvent the wheel when we could learn perhaps from other communities?
Let me answer first. We do have documents. They're published on the Manitoba.ca website. They tell us how to behave. The Riding Mountain Biosphere Reserve has also published Living by the Lake. I wonder how many people know about these documents. They have been circulated around our community. And I would bet that most people who live on the lake don't have a copy and likely have never heard of it. So there is a lot of literature out there that tells you how to behave, but really, I don't think we had much uptake on our public awareness campaign for, well, the province's public awareness campaign for aquatic invasive species. Most people don't know they have a website that is actually pretty good now. They don't know how to find out when the inspection stations are open so that they can be inspected and, if necessary, have their boat decontaminated. And I think it's the same issue with nutrients going into the lake. We have lots of people that live around the lake. There's a few hundred cottages. We're certainly part of the problem. And most people don't know or are not willing to do anything. I don't know which. Hopefully it's the first one. And we need to bring their knowledge up. And to do that, that was one of the things we were hoping we would be able to achieve with the golf course project. It seems to have caught the imagination of some people. It seems like a good idea. We'll probably end up putting a document together that describes some of the issues that could be causing or contributing to our problem. But I think public awareness is a real important part of it, and that's going to take at least a year.
And I'll speak a little bit more to the experiences and research done around the world. I mean, that's certainly what I do. And I'll put in a plug for NALMS here, North American Lake Management Society. So the literature is growing, and it's been there. I spend several hours a week on this in my work with North American Lake Management Society. So yes, there's global research, and you can kind of tap into it through a couple of the North American societies. There's the American Society of Limnology and Oceanology. They're really academic. And the other one is North American Lakes, and they produce a Limnology and Oceanology journal. And the other one is North American Lake Management Society. They produce the Lakes and Reservoirs Management Journal. And that organization is the stellar one for bringing the academic researchers, the government lake managers, and also just cottage owners associations together sharing knowledge. And so if you want to tune into that, their website, that's a big part of where I gain my exposure to the world research, but it's NALMS, North American Lake Management Society. So this is where you find a lot of that sort of stuff, and it's there's a lot of literature searching to be done.
How unique are studies for other lakes, and how transferable might they be to another lake?
If you'll remember earlier tonight, I rattled off a list of questions, right? And I said I could go on all evening. When you have those questions in mind, then the study becomes transferable in that way. And that you arrive at a lake and ask all the same questions. And just through experience, looking at a lake, I'll be able to know what to focus on, because you can't spend all your life and everyone's money measuring everything. So it's transferable in that way. Maybe that's the best way to put it. The questions are transferable and the answers are different for every lake, right? And so with that, if the answers to the questions are different on every lake, then the solutions are probably different on every lake, right?
While we're on this topic, Jay, a question about cost. Could you speak to what a study costs? And I guess there's kind of a range then of dependent on the community involvement and to what degree versus a full-blown in-house study conducted by a consultant.
That's exactly it. And that's probably the good segue, is that depending on the complexity of the lake and what needs to be focused on to answer the critical questions. I mean, those questions that when your answer at first is, I don't know the answer to that. And that would make a big difference to, what the algae are doing. Then you need to dig in there. So you asked for dollar amounts, so I'll do my best here. Two that I have out there right now that we're finalizing budgets on, they provide a fairly good range. This is for the complete study, really understanding the lake, the long-term investment sort of study. And this is with me doing everything. So this is before we start saving money by involving the local people or the watershed districts or what have you. So these are 2 lakes on the prairies. For one, we're in at a budget of about 40, and the other one would take about 40,000. The lake already, so what questions have already been answered, the complexity of the lakes, and also whether we're doing the external loading component, which tends to be really labor heavy. So that's where you're measuring the phosphorus and the stream flow around the lake many times, like even several times a week during the peak of the spring freshet, because it may only last a week, right? It tends to be really labor heavy. So And so that's kind of the range. I've done studies for a quarter of that, a quarter of the bottom end, and I could do studies for a lot more, but I mean, it kind of shows that it's all over the place, but it's not a couple of hours of work, obviously. It's not a few $100.
In your experience, have you seen evidence of funders out there who will help a community to pay for this kind of work?
Well, I'll start. I can't find any. Nobody wants to pay for studies. The Conservation Trust will not pay for a study. They will pay for engineering that is required in order to do a project, but they will not pay for a study. The Lake Winnipeg Basin Program, same thing. The Fish and Wildlife Enhancement Fund, they want physical things to happen. And that's typical. The government of Manitoba, we haven't tried them. I don't think they have very much money left. So I can't find any groups that are willing to fund us. And quite frankly, I mean, the municipality might. That's sort of one area that we're going to explore. But I don't know of any groups that are willing to fund this sort of project. They want to be able to put a plaque in place acknowledging that they helped with doing something.
Yeah, you're right. Purely a study, there's not much out there unless it's a construction or a benefit. And I appreciate that. As I said, it's not success until you fix the problem, right? And I don't like to do studies for the sake of doing studies. There has to be something good coming out of it, something concrete. It may come down to our local regulatory and funding regime or attitudes, perhaps. If you were to put in an aeration system, per se, in Alberta, there's no way you're getting any funding for it until you can demonstrate exactly how it's going to work in the lake and exactly what's going on. So this study would be part of the project. And it's just like engineering on any kind of project. I mean, you don't go build a road without doing some engineering ahead of time, right? And the same goes with these in-lake management projects. Any in-lake management, whether it be phosphorus inactivation or oxygenation of some sort, what kind of aeration do you want? Well, you don't do that without putting in the engineering behind it. And this is the engineering behind it.
Is climate change likely to have an effect on the algae bloom that we see now and into the future?
Yes. Simple question is yes, but maybe not in the way people first think of it. If we're talking a couple of degrees difference, a couple of degrees warmer, people sort of quote the notion that, well, cyanobacteria like heat, and so that those blue-green algae that like heat, so it'll help them grow. That's oversimplified and overstated. It'll have more effect on water stratification, so separation of warm layers and bottom layers, where you get, if you can gain a couple of degrees in warmth to encourage stratification, that's what the cyanobacteria really thrive on. But those are pretty subtle differences in these lakes. And so my big yes is if the climate change, if you're talking about larger storms, particularly larger storms, you know, in June when you don't have much cover on the fields and you've already put down your fertilizer and you have a bunch of erosion, and we're seeing that on the prairies, right? So so we're back to nutrients. In other words, nutrients are our big issue on the prairies here and the biggest challenge to these lakes. And where climate change will increase nutrient inputs by increasing runoff and increasing erosion, this sort of thing, that's where the impact will be. And with that, I'll say that the solution or the answer is in vegetation and soil health. So meaning permanent vegetation on the landscape and soil health that so that the big storms actually contribute more to infiltration and stable soil, infiltration through stable soils, rather than just blasting the topsoil off the landscape, right?
What is internal nutrient loading, Jay, and like what are some of the options to look at or to consider in remediating that situation?
Yeah, internal nutrient loading happens in many ways. So what it is the remobilization of phosphorus that has ended up in the lake over time. And what we see often is that there can be a phosphorus buildup. Like I say, we're 140 years into this on this landscape now. And at some point you reach a tipping point where the phosphorus may have been kind of sleeping down there and then it explodes. Well, why does that happen? Possibly because there's been enough vegetation growth and decomposing matter that now we've dropped oxygen levels to a certain point where you're driving the chemical release of phosphorus off the bottom through it's a reductive oxidative process with iron and other metals and minerals down there. But there are many ways that it can happen. I mentioned another one where swings in pH caused by algae or plants can pop phosphorus off of the minerals like apatite and these calcium-based minerals, that sort of thing. Vegetation can bring it up and bleed it out, and then there's algae that are specialized at pulling phosphorus off of vegetation. There's any kind, there's boats, there's carp, there's worms at the bottom that bring it up, big release in phosphorus. And so that's it, and that's contributing to those algae blooms year over year.
So what are some of the options to fix that situation, Jay?
Well, and this is where you need to know how it's coming up in your lake. It may not be that oxygen issue. If it is the oxygen issue, is it deep water? Is it shallow water? If it's deep water, that is where bottom oxygenation strategies can help. You need to get your dosing right, and you need to make sure you're spreading that oxygen around the bottom, because what you're trying to do is prevent oxygen in those sediments from dropping below a certain point when suddenly the chemistry changes. So that's one way, and it's a very common way. And there's different ways of getting oxygen down there through different oxygenation systems, and with that you have to be considerate of whether you want to destabilize the water column and create mixing, or whether you definitely don't want to. Both situations exist, and then for reasons, I'll say this. One thing to think about when you're doing your dosing is there are three things that putting an aerator on the bottom can do. One is it can create circulation, which brings the phosphorus from the bottom to the top, where you have your algae bloom, right? And another is you're circulating enough oxygen that you're bringing oxygen down to the bottom to prevent the release of phosphorus in the first place. The third is you're circulating the algae, those that like to float, some sink, some float, and so you're flipping the competitive advantage in the lake. So instead of blue-greens, you have other algae. Something like it might be happening in Otter Lake, like I pointed out before. And the caution here is the hardest thing to do is to move the algae and to mix them up. The one in the middle is to move oxygen. And the easiest thing to do is to move phosphorus from the bottom to the top of the lake. So if you've got a blue-green algae bloom sitting at the top of the lake and you're giving it just enough of an aeration shot to move phosphorus, guess what happens? You just fertilized your phosphorus bloom. So that's where things can go wrong. Other than that, there's phosphorus inactivation, alum and phoslock, and a number of methods where you're adding some sort of inactivant that neutralizes the phosphorus down there. There are all kinds of other mixing and oxygenation systems. You're pretty well looking at oxygenation and inactivation. There are some others, and there are others claimed that do not address the problem. Things like, and I'm missing. I mean, I have a whole list of a checklist of things that may work in some circumstances, not in others. But one that comes up locally a fair bit is adding bacteria products. Well, be careful about that. What do bacteria do? They consume the carbon nitrogen tends to take care of itself once you, especially when you take it off the carbon, it goes up into the atmosphere. What's left? Your phosphorus, and you're not doing anything to remove that from the lake with these sort of strategies. So, and I'll just mention that all of these are much harder and much more expensive to do than keeping it out in the first place. I mean, if we could only rewind 140 years in the way we've done some things, right? So
this is an interesting question, Jay. We've heard some about phosphorus budgets, and what is a phosphorus budget, and is it part of the science that would be good for us to understand?
Yeah. So a phosphorus budget, simply think accounting. If there is this much phosphorus available for algae growth, how much of it is coming from external? That's the stream flow measurements that we talked about, and measuring phosphorus coming into the lake. How much of it is coming off the bottom internally? And you're just doing math at this point, more or less, as long as you understand these sources. The phosphorus budget needs to be a little bit more than just the math, though, in that you've got phosphorus coming in from the watershed. So with full accounting, you know how much is coming in each stream, or how much is coming from other sources like the septic systems or the stormwater systems in a development. But that's your external, and then you have your internal coming off the bottom. Important to know what's coming in when, and whether it's feeding the algae right away, or the plant growth right away, or at a later time. So there's a little bit more to it than simple accounting, but that's all it is.
This is probably a good one to wrap up with. I think we all would like someone to probably step up and look after our lake issues. Who, in your experience, do you think should own the responsibility for the status of our lakes anywhere, and the plans that we might make to look after that lake as we go into the future? Who's best positioned to do that, do you think?
Daryl, do you want to take a crack at it? But you've had more direct involvement in looking to different levels of government for funding and that sort of thing. So, and your community, right? Because you're a model for rallying community support, really.
The people who live around the lake have a vested interest. Make the lake better. And I think that's the group that at present is the only group that's going to really do anything about the lake. The province will test the lake because of the beaches, swimming. But they don't come in and do a study on the lake unless they're asked. And years ago, when Al Beck was doing the studies, I think the municipalities asked to have the studies done to see if cottage development was an appropriate thing to do at a number of the lakes around our area. But at the present time, I don't know of any group that is government. The municipality is interested, and they are supportive. And we can ask them for some money to help us with this kind of study. But most of the other funders aren't really going to do anything for us. They're focused on making a difference by doing something physical that they can get credit for. And it is, we're in pretty good shape for that sort of thing, but we're not in good shape for doing a study, as an example. But the people that have the most to lose, I think, are the ones that are going to have to take responsibility. Jay mentioned that there are people in the US where they have programs in place to look after their waters. Unfortunately, we don't have that sort of thing. Our government hasn't really taken that part on. I guess we have a lot of lakes, and we've got so many of them that maybe they don't think that's a big problem.
Maybe I'll pick it up there. And I'll kind of sneak in a question that I was asked: how do you justify spending this kind of money? And just that comment reminded me, Daryl, that we have many lakes here, Western Manitoba, the pothole region. And in terms of justification for should we, now who's the collective we? And I'll come back to that with one more sort of success story. But the justification, I guess, a couple of gut checks in terms of see where we're at. Do they spend this kind of money in other places, other jurisdictions? Absolutely. And you don't have to go far. I mean, in Alberta, people are spending this kind of money for these studies on their private ponds because they know what an asset that is on their property, right? And so here, we have many lakes, so we don't think about it as much perhaps. But where do we spend our money? That's another gut check example. Well, you run up hundreds of $1,000s in engineering and construction fees really quickly to build or to sort of repair and maintain roads that are there to save people some minutes in driving an extra mile, right? So when you compare a road to a lake, well, what's more valuable on our landscape and to our community? And remember that a road can always be rebuilt once it's wrecked. A lake can't be. And we're talking about roads. Well, in the community, how about a truck? I mean, this is what isn't. I mean, the pickup truck, you get a new one in 4 years. The lake, you can't. With that community focus, the biggest success stories I've seen in the work that I've done on the lake management level come out of places in the States where there's a community near or on a lake, and they create their own tax system. Now, I imagine I get a lot of glares. We don't need more taxes, but really, we can point fingers at government saying this is their responsibility. But if there's a community around the lake, like I say, I mean, you can spend many years pointing fingers at various levels of government, or say, this is our lake, let's do it ourselves. And those taxes accumulate really quickly when you've got a community. You have to figure out who's in, who's out, and you have to figure out the logistics of it, the financial logistics. What I've seen often, just to avoid problems with the legalities of it, is communities. It works with the counties, certainly that I've seen. They ask the county to collect a tax that is specifically from and specifically for a board-run lake group, a community on the lake. And then the county simply administers that fund, and they roll it into programs with for lake management. So those are the best success stories I've ever seen. And I don't know if that's, you tell me if it's reasonable in your community. I mean, all the faces out there, but otherwise, I guess we keep lobbying and as a broader provincial community, try to determine what value should be placed on these lakes.
That leads into a very interesting comment, I think, related to that. And the comment is that it may well not be so much about funding as it is about jurisdiction and mandates, and lake and fisheries management is under provincial jurisdiction. I think that's about the extent of our questions, unless there's no more on our chat window here. So I would like to thank both of you for the question and answer period here. You've responded marvelously. And thank you to everyone who submitted questions. That was some extremely interesting questions, and well done, guys.
Yes, thank you very much, Daryl and Jay. Much appreciated. And thanks especially, Jay, for your participation and your enlightening answers. So in closing, I'll say good evening, everyone. Thank you all for joining us, and stay safe.